All right, hello once again. This is Jeff Scott from Jeff Teaches Programming. In the last video that you see up there, we've been working on taking the payroll GUI that we have and converting it into an object-oriented program. I did all the conversions, but I had some errors. I fixed them. I want to run the program and show it to you, and then go over the entire program with you. So here's the program right now, and looks pretty much the same. All these buttons here still work, all right, but you'll see that it's changed a little bit. So I can still go to help. I can go to hourly, but now notice there's just a calculator return and an exit. If I click return, I go back. Piece worker, and I can return. Commission worker, and I can return. Salaried worker, and I can return, and then our exit. So let's talk about what I did, and I'd like to go through most of this stuff that's in here to show you indeed what I have done. So starting here with the regular form itself, I changed all these show hourly form, show piece form, show commission form, and show salary form. All right, and they all look like this now pretty much. We instantiate or create a new form, so FRM hourly or FRM, whatever. Then we set that as the owner, all right? And then we go in and we hide the current form and we show the other one. So it's similar to what we had before, yet it's different. So you can see that that's what we have in there for the hourly. And we have something in there very similar for the piece worker. And I want to make sure because I did a lot of copy and pasting. Hourly, hourly, hourly. Piece, piece, piece. Commission, commission, commission. And salaried, salaried, salaried. Okay? Other than that, I don't think I've changed anything in here. So I just wanted to start with that. All right, and then I'm just going to take them from the top. So we had this person class previously. We've replaced that. All right, and what I mean is for this program, we started with an iPerson interface. As it says, the interface defines what the person object must expose to the outside world. It has no implementation. All right, so it's all the stuff that we wanted to show. In other words, the first name, the last name, the height, and the weight. All right, and then we were going to calculate the BMI and the BMI status. So that's everything that's in the interface. All right, then we had a person abstract class. Looks very similar to what we had before. You'll notice that these all in here say, for these sets, they say protected. Again, there's three major levels in here of access. Private, meaning something is only available within that class. Public, meaning it's available everywhere. And protected, meaning it's available in the class that it has been defined in and in any child classes that come after that. So that's what we set up here for the abstract. All right. And then finally, we've got the person concrete. All right, this is the concrete class. So what do we have in here? Not much, just the constructor. So whenever we want to create a new person, we need to provide them with a first name, a last name, a height, and a weight. By the time we call this, we will have already figured out what the BMI is and the BMI status. So we have those as well. And we take what we're passing in here, and that's what's on the right-hand side of the equal sign for these 6 fields. And we copy them into, all right, what we put in basically for our abstract class. Okay, all right, so that's everything with the person. So let's go next to the calculator. I'm sorry, the BMI. So we've got an iBMI calculator. Previously, we had this BMI calculator that basically did the calculation for calculate BMI and calculate for the status. All right. Now we're starting in here. Remember what this does. This says right here that any class that implements iBMI calculator must provide a calculate BMI function, which must return a double and take in a height and a weight, must provide a get BMI status function, which returns a string and takes in a double. Okay, that's it for that. The abstract class for the BMI, notice what we have in here. All right, it implements iBMI calculator, and that's why we needed these. I mentioned this in an earlier lecture. I'm going to say it again. You can only have abstract methods like you see here in a class that has also been defined to be abstract. But if you have an abstract class, you can have non-abstract methods in there as well as constants. All right? So that's everything that's in the abstract class. Then we've got our BMI concrete class. And that, as you can see, it inherits from abstract. Here's where we do our calculate BMI. Here's where we do our BMI status. And that's all that's in there. Finally, we've got the repository. All right, we've got an iPerson repository, and we've got a person repository concrete. There is no abstract for this. So let's look at this one first. This says, again, that any class that's going to implement the iPerson repository interface must provide an add method, which takes in a person, which is of type iPerson. It should have a list of get people should return a list of iPerson. It should have a clear method and an isEmpty method. Notice again, this is get only. We're not setting in here. We're just checking something. Then the actual person repository class has those methods. Again, the person repository concrete is inheriting from or implementing the iPerson repository. Here's that list. There's the add. There's the list that's going to return everybody. There's the clear, and there's the isEmpty. Now, I am going through this quickly, and I'm hoping this makes sense to people who are watching. All right. So then going back, I believe this is our 4th iteration BMI GUI. I guess we'll find out in a minute. Nope, it's the wrong one. In fact, I guess it's 7th iteration BMI GUI. Okay, so, or is it 8th? This is not the one I'm looking for, I don't think. Oh, I'm working with payroll. I don't even know what the heck I'm talking about here. So let's get rid of all these. Sorry about that. Thought that looked really funky. All right, I think it's 3rd iteration. Pay GUI. I don't think there's a 4th, but let's double check. All right. Not BMI. There it is, 3rd iteration Pay GUI. So we'll bring up the form. We'll do them in order. Then hourly, then piecework, then commission, then salaried. All right. So taking them in order, I've already gone through pretty much of this one. We looked at this already. And I said the major things that were changed in here were the show. So show hourly form, show pieceworker form, show commission form, and show salary form. They all have the same type of setup where we create the new form we want. We set the startup the form we're in right now as being the owner of this, then we hide the current form and show the new one we've just instantiated. So that's that one. All right, let's go to hourly next. All right, so you'll notice in here what I've removed were all the stuff for the overtime, the max non-overtime hours, overtime rate, etc. Why? Because we're doing that stuff in our BMI calculator routines. So the only thing we're keeping in here are the min hours and the max hours, the minimum hourly rate and the maximum hourly rate. This hasn't changed. This is the exact same thing that I went through last time. So I just want to concentrate on what has changed. And that's what's down here. And that is this return. So as you can see, it says, if this form has an owner, show it again before closing the form. All right, so if the owner has been set, okay, show that and close the current form. And that's what I did with all these. There wasn't a boatload of changes I had to make in here. We did have to come in here and do this. This is a kind of a quicker way. It's a more in vogue way to create something. So this is creating a new hourly employee. All right, we're setting the hours that we've put in here. And the rate that we put in here, and we're setting that to our data. Okay, so that one's done. After hourly, the next one that's in there is the piece worker. And you're going to see it's very similar. Again, we did keep in pieces made and price per piece. And we're keeping those in because those are the things that we have to check to make sure they're within range. Just like with the other ones, we kept in hours worked and hourly rate for the same reason. That's what we had to check to make sure they were within range. So again, what's new in here? Same kind of thing. And I guess I didn't mention it earlier, but let's bring that one back again from our hourly. Oh, I guess. So let's bring that back in from the hourly. And that is right here. We instantiated an hourly employee concrete object and called it H employee. And then we called its calculate gross pay to figure out the gross pay. In the same way, we did that and we created P employee for piece worker, and we're calling P employees calculate. This is an example of polymorphism. We're calling the same calculate gross pay, but it's calling basically a different version of that gross pay based on which type of employee we're working with. All right, so next we've got commission. And again, more of the same. These are the things that we have to validate, that percentages between 0 and 30%, that sales are between 0 and 100,000. All right, and again, we come in here just like we have been doing, and we instantiate a new commission employee called C employee. All right, passing in that percentage that we set here and the sales figure that we set here. Then again, showing polymorphic behavior, we're calling that commission employees calculate gross pay. Finally, for the last one, which is our salaried, more of the same. We keep our min salary and our max salary 0 and 100,000 so we can make our checks. This is the simplest one of all because there's only a salary. So we bring that in, and we wouldn't have even really had to have done that because gross pay is equal to salary right there. But that might change in the future. That's kind of a good point. If this calculate gross pay changes in the future as far as how it's done, since I'm calling it here and you don't see it because the implementation is hidden, we can make that change and there's no kind of problem. So I've shown you this now. All right, and that was the idea behind this. Now I want to mention to you, one of the reasons that I didn't finish this yesterday is each one of these forms, and I'll just go to the hourly, has what's called a designer form. When I went and made all those copies and took things and basically copied things over, etc., I hosed this all up. This was huge, this file, and now they're all pretty small. So I had to go through it and get rid of all the errors, and believe me when I tell you, I had a lot of them. All right? So what have we tried to do right here? We did what's referred to sometimes as refactoring. We took a procedural C# WinForm application. We applied object-oriented design principles to it and made an object-oriented design program. All right? Now, what's the problem with what we had? And the answer is really nothing. It worked. However, the form had too much power in here. And what I mean is, each one of these forms displayed the GUI, validated the input, calculated the gross pay, controlled the navigation back and forth, controlled the exit, and that violates one of those things we talked about a while back in these solid principles, and that's the single responsibility principle. We replaced this with classes, and a class should have only one reason to change. Right now, if the pay changes, we probably would have to modify the user interface, and that's poor design. But since we've hidden it now in the implementation of the classes, if we change it as I showed you before, the person running the program is none the wiser. Second, there was really no abstraction in the program before. We didn't have a concept of an employee. All right? We didn't really have a concept of an hourly worker or a commission worker or a piece worker or a salaried worker. The form itself was kind of the worker. That's not the way things are supposed to be done. We had no polymorphism. Each form calculated the pay differently, but there was no shared interface. There was no common calculate gross pay method. All right, and there is now. So what ideas did we apply? All right, we figured out that we needed an employee class, an hourly employee class, a piece worker employee class, a commission worker employee class, and a salaried worker employee class. All right. And what we ended up doing in here, amongst other things, in this payroll library, get rid of that, and that, and that. Come on. You can see all the stuff that got put in here. All right. Once I get rid of some of these, close some of these things that are open. Think about this. Okay, the type of employee should be calculating the pay, not the form. Okay, we created interfaces. Remember what the interface does. It says what every employee is able to do, the what, not the how. What should they be able to do? Calculate their gross pay. All right, we used interfaces. We programmed to the interface All right, so we didn't have to change much of the way this looked. We got rid of some buttons. Every employee type now supports the calculate gross pay. The user interface doesn't care itself how it's calculated. All right, so after those interfaces, we created abstract base classes. Remember, interfaces define what should be done. Abstract classes help show a shared structure. They represent, in our case, we started with a general employee. They provided some commonality as far as the inheritance and the stuff that we worked with. So we worked with abstract classes. We even worked with inheritance. We worked with polymorphism. All right. Then we created concrete employee classes. Each worker type is now its own object. We had an hourly employee object. We had a PieceWorkerEmployee object. We had a commission worker employee object. We had a salary worker employee object. All right. That's true encapsulation. We had data and behavior. We did some method overriding. Our business rules, how things are done, is now different. It's distinct. It's disjoint from the user interface itself. All right. Each class knows its own rules, etc. All right. Again, we used polymorphism. Different objects responding to the same message differently. We did some refactoring of the forms. All right. Previously, the form validated, it calculated, it formatted, and it displayed. Now it does less than that. It still collects input, it still validates that input, but now it creates an employee object for each type, and then it displays the results. So the form no longer knows the rules for how gross pay is calculated, doesn't care. It's delegating the work to the object. You can look at it as the object basically owns that behavior. Okay. Every form now basically has identical code for navigating back and forth, for exiting back and forth. Okay, we changed it. We used inheritance in this program. All forms now basically are set up pretty much the same. Our design is better. You may or may not remember this, but we talked a little bit before about solid principles. All right, the SRP, we have our business logic is not in the form anymore. The OCP, the new employee types worked without modifying our form greatly. Our LSP, any employee can work with his base class. The ISP, we had a small interface. The DIP, the user interface, depends on abstraction. All right. If we have to change pay rules, we don't have to worry about the user interface anymore. All right. So I guess, to kind of close this up, forms are not employees. Employees are not our employees. Forms should not calculate gross pay. Employees and employee types should calculate their gross pay. Forms should only be displaying. That's pretty much it. So I'm done now with the portion I wanted to do that discussed object orientation. What I'd like to do is to take, and just for now at least, I think at least, I'm probably only going to work with the GUI version of both the BMI app and this one that you see here, but I want to bring in databases. So in the next video that I go over, I'm going to talk about what databases are. Hopefully we can do that in one video, but if we need more, not a problem. All right, so get that out of the way. If this ever happens to you, see how that got all screwed up in here. What is it again? I think it's window. Reset. Default window layout for the environment. Okay, That should have reset it. All right, I'll be back in just a couple minutes.